This is homework help for lesson 4.6, question number 5. It has to do with a radioactive element that is decaying. So we have the half-life of iodine-123 is 13 hours. So the half-life is 13 hours, which means it decays to 1/2 of its original mass after 13 hours. After 26 hours, it decays to 1/4 of its original mass. And we need to determine what fraction of the original amount will remain after 52 hours. So I'm going to just go ahead and say, here's a problem-solving strategy. I don't know what fraction is going to remain, but I know a few things. I know that after 13 hours, half of it remains. And I know that after 26 hours, that's twice as long, so it's another half-life period. It tells me that 1/4 remains. Now what I know about half-life period is that to get from this to this, I multiply by 1/2, right? Well, let's see if we can continue our pattern to get our answer for question A, which is what happens after 52 hours? What fraction remains? What's 26 plus 13? 39. So that's another half-life period, which means there will be half as much. So what's half of 1/4? 1/8. 39 plus 13? Well, that's 52. What's half of 1/8? 1/16. What fraction of the original amount is left after 52 hours? 1/16 is left. Okay?
That's A.
I'm going to go ahead and do B a little bit differently. Yes, you could just continue this down two more lines and you'd get 78 hours. But what we want to show, I'm going to do B a little bit differently. We're going to do this the same way we did our examples yesterday in the lesson. So if the half-life is 13 hours, I need to find out how many half-lives are in 72 hours. Okay? If you put that in your calculator, you get... Anybody got a calculator?
4, 5, 6, 7, 8.
But maybe you have to divide by 26.
Oh, sorry, this is supposed to be 78. 78.
Can you divide it by 26 though?
I could divide it by 26, but then I would have to use the quarter life, and I want to use a half-life. So 78 divided by 13 is 6. Okay? So there are 6 half-lives. That means that the original amount, whatever it is, I don't know what it is, but it's going to go through 6 half-lives. It's going to go through a half-life and then get multiplied by a half, and multiplied by a half, multiplied by a half, 6 times. So all I have to do here is say top times top times top times top times top. So that's 1 times 1 times 1 times 1 times 1, which is just 1. And bottom is 2 to the power of 6. So again, I could just count 2, 4, 8, 16, 32, 64. Okay? And let's just double check on our pattern just because. We could go 65 and then 78. Half of 1/16 is 1/32. Half of 1/32 is 1/64. Okay?
What about C?
C says write each fraction as a power of 2 with a negative exponent. So we're writing each of these fractions, this fraction right here, and this fraction right here, as a power of 2 with negative exponents. It's not that difficult really. If this is 1/2 to the power of 1, and this is 1/2 to the power of 2, and this is 1/2 to the power of 3, 1/2 to the power of 4, 1/2 to the power of 5, 1/2 to the power of 6, then all we need to do is use our rules for exponents, and we know that this is the same as the reciprocal of the negative exponent. So if we take the reciprocal of 1/2, which is 2, and then change the exponent to a negative. This one, instead of being, sorry, this is, I lied. Let's do one step in between. This is 1/2 to the power of 1. This is 1/2 to the power of 2. 1/2 to the power of 3. 1/2 to the power of 4. 1/2 to the power of 5, and 1/2 to the power of 6. Now to express them with a base of 2 and a negative exponent, now we take the reciprocal and change the exponent. So this is 2 to the power of negative 1. This is 2 to the power of negative 2. Right? We're just taking the reciprocal. The reciprocal of 1/2 is 2. And the opposite of the exponent 3 is the exponent negative 3. Reciprocal of 1/2 is 2. Opposite of 4 is negative 4. 2 to the power of negative 5. 2 to the power of negative 6. Okay?
So which one is the answer?
So for C, you needed to find this expression for 78 hours and 52 hours. So the two answers would be 2 to the power of negative 4 and 2 to the power of negative 6.
Yeah, those are gonna...
Okay, quick final notes on domain and range. What are they? Domain and range talk about the values of x and y that the function can actually have. So we're talking about parabolas. I'm going to draw an example in a minute, but first I'm going to define domain and range. Domain. All the values of x included in the function. All the values of x included in the function. So the domain is considering the values of x. That's all the horizontal options. The range is all the values of y included in the function. So the range refers to all of the values of y that are part of the graph, part of the function that the parabola can satisfy or take. So I'm going to go ahead and draw a parabola. And I'm going to just say that the vertex is 1, 5. And it opens down. So in this case, this parabola is going to go forever and ever and ever, this leg and this leg. Which means if it's going infinitely this direction, and it never goes straight down, it's always going out a bit, that means it's actually going to go, its domain is all the values of x. I can plug in x equals 1 billion into this thing and I'll still get a value for y. So all of the values of x are included in our green parabola that we drew. There's no restrictions. Any value of x from negative infinity to positive infinity is included in the green parabola because it goes forever. Now let's look at the range. Is the range also infinite? Or is there a restriction? Good. If I look going down, there's no restriction. It can go to negative infinity. But if I look going up, there are no values for y up here. As a matter of fact, there's no values for y above y equals 5. So the domain for the graph that we've drawn, we would say there are no restrictions on x. No restrictions on x. That means x can be any value in the whole world. Another way to say that using math language and symbols is x belongs to the set of real numbers. X element r. This is a funny E with, it's like a C with a line through the middle. It means belongs to. X belongs to the set of real numbers. That means any number in the whole world could be x. Okay? So that means if this function was y equals negative x minus 1 plus 5, I could put any value in there for x. and I would still get a y. There's no restrictions. Now the range is different. There are restrictions on the range. The range deals with all the values of y, right? The range is all the values of y included in the function. Well, y belongs to the set of real numbers as well, but this means this long straight up and down line means such that y belongs to the set of real numbers such that y is less than or equal to 5. So the range of this function is y is less than or equal to 5. And we got that right here because we know its vertex is at y equals 5, and we know it opens down. So there's no value, no green value greater than 5. 5 is the greatest value. So all the other values of y are either less than or equal to 5. This is the domain dealing with the x values of the function. This is the range dealing with the y values of the function. Now, think of every parabola in the whole world. What's going to be true about the domain of every single parabola you ever deal with? There's no restrictions. What's going to be true about the range of every single parabola you deal with? There is a restriction because all of them have either a maximum point or a minimum point. Okay? If it had a minimum point, and let's say the vertex was at 0, 0, 4, then we would say y is greater than or equal to 4. That would be the range of that one. Okay? There's some examples for domain and range. Now you should be able to do your assignment.